Good morning, everyone. My name is Austin Moeller. I'm the Aerospace and Defense Analyst here at Canaccord Genuity. Today, I'm joined by Pete Canito and Bill Reed, the CEO and CFO of Redwire, a space infrastructure company. So, Pete, if you could just give us a little overview of the company and give investors some insight into the outlook here as the company goes through the de-SPACing process.
Yes, thank you, Austin, and appreciate being here today. Thank you for your time. And what I'm going to do here is I'm going to very quickly go through a presentation that we uploaded to the portal, which is an excerpt from some of our Analyst Day presentation, which is, of course, all available online. But I'm going to go quickly through and just hit a couple of the slides. I won't go through the whole thing so that we can spend the majority of our time on some Q&A. So next slide, please. As per expected, these first couple of slides, I encourage everybody to read through them at their own timeline. And I just want to remind everyone that all forward-looking statements are subject to various assumptions, risks, and caveats, as noted in our SEC filings and our presentation. And of course, actual results may differ materially as such. So next slide. So just to start out with, I wanted to hit on a key highlights about Redwire that we think are really important. And it's Redwire from an investment perspective is really about filling that middle market with a pure play space investment at scale. Currently, the space industry is highly fragmented. And on one side, you have really large diversified aerospace primes, such as Lockheed Martin, Boeing, and others, very familiar to most people. And they're great companies and they bring a lot to the space community and have really great history, and particularly in their flight heritage, which is really important in space. But from an investment perspective, an investment in a large diversified aerospace prime includes an investment in aerospace and defense in addition to space. Then there really isn't much of a public middle market for space, for pure play space companies. And then you have a very highly fragmented market on the other side of small businesses that really come in two flavors. Niche companies that dominate a particular technology area and have tremendous flight heritage and have been around for many, many years, but haven't scaled, whether it's due to a lack of capital or a lack of sophistication or both. And then you have a number of new space entrants that have some disruptive technologies that are highly innovative, but don't have a lot of flight heritage, which, as I mentioned, is really important to establishing yourself as a space player. What Redwire essentially endeavors to do is to fill that middle market with our first mover industry consolidator advantage by bringing some of the niche technology providers with extraordinary flight heritage together with some of the innovative disruptors that have proven they can pass or cross the valley of death and become cash flow and revenue positive. And that's essentially what we're doing here. We are focused on the space infrastructure segment, and we'll get into what we mean by that in a second. But this has a large market, and because of our approach of combining flight heritage plus disruptive innovation, we're starting from a very strong financial position. I like to say we have a blue chip foundation with venture optionality. So unlike some other strategies in the space community, we're revenue and cash flow positive today and are positioned to maintain that stance going forward. Next slide. I'm going to skip ahead. Delia, if you could get to the slide that shows, yes, the commercial space commercialization. So where is Redwire positioning ourselves? So when you think about the evolution of space and the space industry, and really new space, there's been a lot of focus on launch. And that's very exciting for us because launch is a key demand signal for space infrastructure. And with the reduction in launch costs that you've seen through such innovations as SpaceX introduction of the reusable rocket, as well as the number of small launch companies that have entered the market, you have a real reduction in launch costs, which is a huge tailwind for space infrastructure. And at Redwire, that's what we're focused on. And when I talk about space infrastructure, sometimes we like to talk about the projected growth of 6,000 satellites in Earth orbit today, going to 50,000 by 2030. But for Redwire, although that is a big segment of our target market, it goes beyond that, including cislunar, lunar, big NASA programs such as Artemis, even out to deep space and the commercialization of space ultimately. So that's the area we're focused on. If there is a segment of infrastructure in space, that is part of Redwire's addressable market, and you'll see why in a second here. So if you go to the next slide, what particular areas are we focused on? We have a very broad, diversified portfolio of products and services purposely, and that's because, as we like to say, when space wins, Redwire wins. We're really positioning ourselves to be a key enabler for the future applications and missions of space. So we work across all three segments of the market, both the national security, civil, and commercial space segments. And as a key mission enabler, what we do is we provide those foundational technologies that are important to anyone that wants to operate in space. As such, the analogy that we like to use is if you think about terrestrial infrastructure, there are these building blocks such as power, compute power, communications, capital equipment, engineering, design that are important building blocks to a terrestrial economy. What Redwire is providing is those same key building blocks to a space-based economy, and that's power, such as our solar arrays, navigation and control, such as our star trackers, sun sensor, and core avionics packages, in space manufacturing capabilities, such as our in-space 3D printing capability, and the like. So as example, we just recently launched yesterday a regolith printer demonstration on the ISS that'll demonstrate the ability to 3D print material using moon simulant regolith, or what regolith is basically the material you have on the moon. This is a critical capability for someday with the Artemis program. We land on Mars, the ability to use lunar regolith to print structures and things like that. So these are, it's just one of many capabilities that we have, but these are the core underlying technologies that I wanted to hit on that talk about what we do. And if you go to the next slide, you'll see, go to the next slide, please. It shows some of our products and our focus areas. You'll see examples of that in terms of, I encourage you to look at the slide in the interest of time, but we're really focused on 5 core areas: space commercialization, digitally engineered spacecraft. This includes satellites in both low Earth orbit and GEO, as well as spacecraft that go beyond GEO. What's called OSAM, on-orbit servicing, assembling, and manufacturing. This is the 3D printing on orbit that I think we're going to talk a little bit about in Q&A, as well as those advanced sensors, components, and deployables that underline that critical infrastructure of space, let's call it. And then, of course, space domain awareness and resiliency, which is very important from a national security perspective, as such as space becomes a contested domain. So I'm going to stop there, and that's kind of a high-level overview of Redwire, and open it up to you, Austin, for some Q&A.
Thank you, Pete. So just to start here, can you discuss Redwire's strategic approach, which you called a picks and shovels approach to being a provider of space infrastructure, and why is that so crucial to the development of the broader space ecosystem?
Yeah, that's an excellent question. So if you think about what we're seeing happening in the space industry right now. There's a number of just fantastic new business models that have been enabled by the reduction in launch costs. So you see a lot of companies that are coming out that have great remote sensing constellations through a number of different phenomenology, video, IR, SAR, RF, all these types of things. And you have a number of companies that aspire to put proliferated constellations in LEO for communications. All of these business models have rely on a subset of core infrastructure like power, avionics, navigation and control, and ultimately the ability to put very large structures in space for large aperture antenna and the like. That is where Redwire is focused, is those advanced technologies that underpin the future of space infrastructure that are going to enable all of these different new missions and applications across all three segments I mentioned. Some of it includes things that are very well known that we have a tremendous amount of flight heritage on, such as our sun sensors that are on all the GPS constellations, such as our solar panels, including the three that we just were just attached to the ISS to give the next generation of power to the ISS. And some include more advanced technologies like our on-orbit manufacturing and 3D printing that will allow us to create really large structures in space that couldn't be launched fully assembled. So that's what we mean by the picks and shovels, is that these next generation, let's call them killer apps for space, are going to rely on Redwire infrastructure from which to operate.
Great. Yeah, definitely sounds like a very important part of building out the space industry as we go forward here. Just to sort of touch on a point that you mentioned and pivot into in-space assembly and manufacturing. So can you explain why in-space assembly and deployable space mechanisms are so important to developing large spacecraft platforms, space stations, et cetera?
Yeah, excellent. Many people may not be aware of this, but the vast majority of the cost and a significant amount of the weight that goes into the development of space infrastructure is there with one single purpose, and that is for the infrastructure to survive launch. Launch is a very harsh environment. As you can imagine, the rocket has just incredibly high levels of vibration. There's G-forces that have to be, that the equipment has to be able to sustain. By being able to print and assemble on orbit, you can eliminate all of that cost. So now the way we would typically deploy infrastructure is we would kind of build it out, harden it for launch, fold it up in kind of an origami type structure, and then put it into a rocket and launch it out. And then once it's there, it's deployed, and all that money that was spent on hardening it for launch and all that extra weight, for all the different materials you need to ensure it survives launch is now no longer necessary. What in-space manufacturing, and we have a marquee program around this called Archinaut that is going to be a small sat that prints its own deployable structures for their solar arrays. By doing it on orbit, all you have to do is send up the material, which it's very easy for that material to survive launch, and then print the structure when you get on orbit for a very, benign, at least from a vibration perspective, environment in space. And so that's just kind of one example of how in-space manufacturing can help reduce the cost and weight associated with launch. And then even beyond that, the ability to create lunar habitats or really, kilometer or even 100-meter size structures in space, there's just not enough room in a rocket to fold all that up fully assembled. So by being able to create that on orbit, you can create structures that are larger than anything you could launch from a volume perspective. So that's another key advantage as well.
So just sort of on that point, one of the main challenges of especially in human space travel is the lack of gravity, which of course has a very negative impact on the human body. So would in-space manufacturing and getting out of the size limitations of that rocket payload fairing make it easier to build like a centrifuge for artificial gravity?
Well, yeah, anything that is going to require a very large structure will require some form of in-space manufacturing. It virtually is anything as we start to build out the infrastructure in space, you're going to require these technologies. And it's not only technologies that'll be printing materials that we bring with us, but it'll be technologies that use what they call in situ, or the resources that are available in space in order to do building as well. And I talked about our example of the moon regolith printer that we just launched to the ISS yesterday. That's a great example of, if you're going to build lunar structures, you're going to need to be able to 3D print out of in situ resources. In addition to that, when you start talking about people living and working in space, we're not just going to be able to put a launch up every time they, lose a wrench or, need some new tool or capability. It's much easier to just communicate a CAD file or a print file, if you will, that can be uploaded onto a 3D printer that can create whatever they need while they're there. So that is a critical capability associated with our 3D manufacturing in space.
And just on the Archinaut, when could we expect that the first launch of the Archinaut will be, and what will be the first structures that it builds in space, and could it be tasked to build other structures once its initial demo is complete?
Yeah, the 3D printer is obviously configurable, and it'll be launched in 2023, and its first task is to print a deployable structure for a solar array. So it'll go up as just the box, it's, the satellite itself, the bus, and then it'll print the solar arrays that'll be then deployed out from the satellite. As a matter of fact, that the Archinaut capability not only demonstrates our ability to 3D print a satellite on orbit, but it'll have a robotic arm that'll enable assembly too. And we do have a robotic arm as part of our product portfolio, and that robotic assembly is a key part of this building out of space infrastructure, in addition to the 3D printing.
Awesome. So as everyone knows, you guys are currently in the process of completing a SPAC merger with Genesis Park. So I was just wondering if you could give investors just a timeline and an overview of how quickly that process will be completed, and I guess the plans for the company once it's listed on the exchange.
Yep. So nothing has changed from what we briefed on our analyst day, and that is we are on track and on our schedule for a Q3 close.
And once the merger is completed, obviously a significant portion of your strategy involves future M&A activity beyond what you've already acquired previously. So what types of companies is Redwire looking at for potential future acquisitions to build out that space infrastructure portfolio And how soon after the de-SPACing process might you consider engaging in more acquisitions?
Yeah, that's an excellent question. So one of the, I'll step back a little bit and then I'll answer your questions. One of the things that I really like to talk about when I talk about Redwire, particularly to investors, is how unique this team is from the perspective of being able to build out this middle market company from an M&A perspective. We not only have a tremendous amount of management experience in M&A, but we've been able to successfully hone all of our processes internally together as a team over the last year and a half as we were highly active in M&A. And that is a critical competitive advantage for us because there are a number of space companies out there that aspire to do M&A, but they're mostly coming from a technical background, and that makes us truly unique. So our growth story post-SPAC is not only just the incredible blue chip foundation plus venture optionality associated with the technologies that we talked about, but also our ability to be that continue to be that first mover industry consolidator and successfully grow both from an organic and inorganic perspective. And as such, our plans include M&A very shortly after de-SPAC. We have not slowed down in terms of continuing to constantly build our pipeline of opportunities and engaging with a number of different companies across the industry in order to make sure that we have full momentum right after our de-SPAC. And in terms of which companies kinds of companies, I would go back to those strategic focus areas, and they're going to be primarily adding capability to those 5 strategic focus areas, which include commercial LEO, digitally engineered spacecraft, advanced sensors components, resiliency and space situational awareness, and OSAM, the on-orbit servicing, assembling, and manufacturing. We'll continue to build out our positions in those areas.
And Pete, just when we look at the company's existing backlog, as stated in the presentation, the $280 million, that's the backlog that's currently in the pipeline, and then there's a broader $500 or so million number that includes opportunities that are considered high probability. Can you just go into what's included in that backlog and in terms of what's already in the pipeline and what's a high probability of win going forward?
So we can talk a little bit about, in fact, we give Bill a minute here of the mic to talk a little bit about what's in the backlog at a general perspective and how we look at backlog specific, but we don't obviously comment on any specific opportunities that are in that pipeline and comprise other than the public stuff that we've announced. So Bill, why don't you give us a quick overview of that 280 and the 500?
Okay, I'd be glad to. Just very quickly, so when we think about backlog, we break it down into 3 buckets, and that's contracted backlog, that's items in negotiations, and amounts to complete program scope. So what's contracted backlog? That's physical purchase orders, contracts signed, deliverable that we are acting on today. So just deliverable backlog, future revenue off existing work that we're working on. In negotiations are exactly what it sounds like. This is where we have been selected by the customer, and we are in the final stages of getting the T's and C's in place and papering the agreement. And then the third group, that amounts required to complete program scope, this is additional funding and contract coverage on the programs that we are working on today. This is not really pipeline. This is just extensions of our current programs where we may be operating on a 4 or 5, 6 year program, and we've gotten coverage for the first year of the program, but we fully expect that program to continue through completion. You spoke about the other $220 million that we brought up in our analyst day. Those are proposals that are either in our customers' hands that we expect to get positive feedback against, or proposals that we are about to release. So that's an additional visibility into another 220 million of future revenue, near-term future revenue that we are driving for as of today.
Great. Well, we're running up against the end of the time here, but thank you so much, Pete and Bill, for giving us an overview into Redwire, and I look forward to speaking with you soon.
Yeah, it was our pleasure. Thanks for having us.
Yeah.
Thank you
Thanks
all.
again.